Astronomy has a lot of subspecialties: radio astronomy, astrobiology, archaeoastronomy, and astrometrics, just to name a few. But some subspecialties have their own subspecialties. Take planetary astronomy. You can study planetary geology, planetary interiors, orbital dynamics, and celestial mechanics. But today we're going to talk to a planetary astronomer who focuses on near-Earth objects, or NEOs. Despite life trying to get in the way, I was able to talk to Dr. Richard Binzel. Dr. Binzel is currently a professor of planetary sciences at MIT, but he's had a pretty amazing career. He helped invent the Torino scale, discovering minor planets, and even having an asteroid named after him. So what is planetary astronomy, and why near-Earth objects?
Everyone knows that astronomers use telescopes, but if you're an astronomer who uses a telescope mainly to look at planets in our own solar system, then that's what we would call a planetary astronomer. Well, as a planetary astronomer, I've always been interested in things that are close by, sort of in our celestial backyard, because one, you can get a lot more data on them, but the other is that we have the chance to explore these objects with spacecraft missions. And so among the things that come closest to the Earth, sometimes impact the Earth, are the near-Earth asteroids. And so I've been interested in those because they deliver samples to the Earth, the samples that we call meteorites. And also, I would rather not see the human race suffer the same bad day that the dinosaurs did 65 million years ago. Yeah, I think for two reasons. One, we get meteorites from the near-Earth asteroids. And so these free samples, we'd like to know where they come from, because these meteorites, which generally are 4.5 billion years old, date back to the very beginning of our solar system, when all the planets formed and when the ingredients for life came to Earth. So the meteorites are like time capsules going back to the beginning of how our solar system formed. And we think they come from the near-Earth asteroids, and the near-Earth asteroids we think come from the asteroid belt. So there's this chain of logic and this chain of scientific sleuthing, if you will, that traces from the laboratory to objects in space and back in time almost 4.5 billion years ago. Yeah, the Torino scale is a 10-point scale from 0 to 10 that tells you for any newly discovered asteroid whether or not to worry about it. All right. And so what you don't ever want to see on the Torino scale is 8, 9, or 10, because those are the level of a certain impact. In other words, we've got an object and we know it's going to hit the Earth. And to get to level 8, it has to be a significant size, like Tunguska sized or a bit larger. And 10 would wipe out the dinosaurs again. So we'd rather not be at 8, 9, or 10. But anyway, at the lower levels of this scale, it's just simply that we've discovered an object and we can't rule out that it's going to miss the Earth in some future decade. And so we recently had an object named 2024 YR4 that reached, I believe, a 3 on the Torino scale, which simply meant it had about a 1% chance or a few percent chance of hitting the Earth. Or in other words, we were only 97% sure that it was going to miss. And until we were 100% sure it's going to miss, we're going to keep following it and keep tracking it. And so it's a little bit like a Richter scale, where if someone tells us, if you live in California and someone tells you there's going to be a magnitude 3 earthquake tomorrow, you don't care. You probably have one today. It's just a normal kind of event that occurs when you live on a seismic fault line. Similarly, as we discover more and more asteroids, it takes time to track their orbits, to see their trajectory, or to measure a long enough trajectory of that asteroid so that we can calculate its future position for many decades, if not centuries into the future. And sometimes it just takes months to get a long enough track of that orbit so that we can be sure we know where it's going to be for many, many decades into the future. And so this was just a recent case of an asteroid that was going to come close to the Earth. It's probably going to be out at about the lunar distance in a decade or so. So it's going to miss the Earth, which is what we expected all along once we had enough data. But it just got a low ranking on the Torino scale just to basically get astronomers' attention. I was a little surprised by how much public attention it got. I think we're going to have a lot more discoveries like that as new telescope capabilities come online. And so maybe we'll get used to things at the lower end of the scale. And that's just fine. That's why the scale is there, so that we'll get used to the idea that a 0, 1, 2, or 3 on this scale is sort of an everyday discovery, and astronomers will pay attention, but it doesn't have to make the newspaper, so to speak. Well, I'll tell you about one asteroid project that I'm working on, which has to do with the year 2029. And it happens to deal with the date Friday, April 13th, 2029. This shows that nature has a sense of humor because there's a very large asteroid named Apophis that is going to go safely past the Earth, very close, but safely past the Earth on Friday, April 13th, 2029. The Apophis asteroid is bigger than the Eiffel Tower. It's about 340 meters across. And it is going to come closer to the Earth than orbiting geosynchronous satellites. So that's how close this asteroid is going to come. But I always say 3 times that it will safely pass the Earth. It will safely pass the Earth. It will safely pass the Earth. But what's exciting is the Earth is going to strike back. The asteroids sometimes hit the Earth, but sometimes the Earth can strike back because the Earth's gravity, the Earth's tidal gravity, is going to pull and stretch on that little asteroid as it goes by. And I'm working on trying to get a flotilla of missions that will be there watching what happens to that asteroid as the Earth tugs on it and changes its orbit and sends it tumbling along its way. Because how that asteroid responds is going to tell us how it is put together on the inside. And we've never before ever been able to measure the inside structure of a small asteroid. And so nature is giving us this natural experiment that can tell us how these asteroids are put together. And that could be very useful someday if we ever had a serious asteroid threat. This is a chance to learn how these things are put together on the inside. And so if we ever had to seriously push on a large asteroid in the future, and hopefully not, and probably not, but just in case, this would be the most advantageous knowledge opportunity we would have. And we think an asteroid like Apophis, as large as Apophis is, we think that large asteroid does not come this close to the Earth except maybe once per 1,000 years. It's incredible that nature is giving us this natural experiment. And it's kind of like the Shoemaker-Levy 9 impact in Jupiter back in 1994. It's just an amazing natural experiment that we devoted a lot of resources to study. And I'm trying to motivate a lot of resources to study the Apophis asteroid as it goes by in 2029. The reason we should be finding these near-Earth asteroids is not because there's any imminent threat. The chances of a major impact in any given year are incredibly small. A major impact is maybe once every 100,000 to a million years. And so the chances in any given year are incredibly small. But the point is they're not zero. And until we discover what's out there and track their orbits and just make sure that there's no asteroid with our name on it, then we're not doing our job. I don't think, I think planetary astronomers have a job to do, and that's simply to go through the work it takes to discover these objects. And effectively, we're buying insurance. By knowing what's out there, it's a form of insurance that we won't be taken by surprise. And because we now have the capability to know what's out there and not be taken by surprise, I think it's an obligation to do it. I think it's an obligation for astronomers to simply know what's out there because we can know what's out there. And we should do our job and just make sure there's nothing headed our way for many decades, if not centuries into the future. Small stuff, arrives all the time as meteorites and nice meteor showers and things like that. But large events like the bad day for the dinosaur should never take us by surprise at this point in our technology. I always recommend the moon. Spend a lot of time looking at the moon day by day or night by night to watch how the terminator, that's the daytime, nighttime separation line on the moon, watch how the craters and the shadows in the craters change from night to night, starting with a crescent moon, moving through the first quarter moon to the full moon. That's fascinating in of itself. And when I first started with the telescope, I probably learned the names of 200 or 300 different craters on the moon and learned to identify them by sight and just to watch the moon. And it's easy to find in a telescope, obviously, and you can get used to the telescope. It can be uncomfortable bending over. You find out, you use a stool or something to sit and look through the eyepiece, and then you're out among the night sky, and while you're looking at the moon and you're taking a break and you just look up, see an occasional meteor, you'll see bright stars, you'll wonder what those are. And so the moon is a great pathway forward in enjoying the night sky, and almost any small telescope will do a very nice job just looking at the moon and the craters on the moon and the sea. The first thing I would recommend is going to a meeting of a local astronomy club. I know Austin has an astronomy club. Almost every city has an astronomy club. You'll find like-minded people, some who are in sort of at an entry level or just a basic curiosity level, all the way to people who have really sophisticated backyard observatories. And I think just getting to know some people that can advise you as to how to best pursue your interest. You'll find someone who's right at your level or can bring you to the level you want to go. And these are generally really good groups. So that would be a great place to start.
Our journey into planetary astronomy is far more than exploring distant worlds. It's about understanding our own cosmic neighborhood and safeguarding our planet. Diving into the study of near-Earth objects challenges us to look beyond the night sky, to grasp the reality of potential impacts through systems like the Torino scale, and to appreciate that our cosmic vigilance is integral to our future. While the odds of a catastrophic encounter remain low, the relentless pursuit of knowledge and preparedness unites scientists and enthusiasts alike. Thanks for watching. If you like this video, smash that like button. Click that subscribe button for more content from Texas Dark Skies, and ding that notification bell to get notifications when new videos are posted. Take care of yourselves, and in the words of my favorite personal astrophysicist, keep looking up.